Hey everybody, it's Joel Irway with DailyFEExamPrep.com, and we've got another member request video for you coming at you today from Chris, who is part of my FE Focus Formula Accountability Program, one-on-one coaching program. So Chris asked me to help him solve and explain this problem right here, which is actually in statics, and it's all about resultant forces, okay? He was having a problem with some of the sign conventions, and he wondered why that 90 Newton force over there was shown as a positive value. So what I'm going to do is I'm going to explain this problem to you, and I'm going to go ahead and solve it, and then I'll identify where he's getting screwed up, where he's getting tripped up, and explain what's going on there. Okay. So the problem here that we've got today is the 5 forces shown act at point A. What is the magnitude of the resultant force? Okay, so this is a concurrent force problem, which means that there are forces acting on a single point, and we want to find the resultant. So in order to find the resultant, let's go ahead and define what the resultant really is. What's the definition of a resultant? Well, the resultant is basically just the sum magnitude of 2 or more forces. So it's just the sum magnitude. So it's shown as one force. The sum of all of these forces is shown as a single force. Very, very simple. So what I want to do is I'm going to point to this where it is in the NCEES supplied reference handbook, and on page 63 here we've got all sorts of formulas down here for where we can find the resultant, where we can reference for the resultant. And what we're going to focus on today is the X and Y components of the resolution of a force, which is defined here. So we've got the separating a force into components when the geometry of force is known is the resultant is equal to the sum, or excuse me, the resultant is equal to the square root of the sum of the X components plus the Y components plus the Z components squared. Now in this problem we only have 2 dimensions, so we're not going to worry about the Z component at all, so we can just completely drop it from the equation. And I have a feeling that if you see some of these problems on the exam, you're probably only going to deal with 2 components as well, 2 dimensions. So that's just my hunch. I can't really speak from it. I can't guarantee that, but that's just my hunch. So page 63 is where you can find these formulas. So let's go ahead and not waste any more time, and let's jump right into how to solve this problem. So what we want to do is obviously we want to separate these values. We've got 5 forces here, and we need to sum up the values and find the values of the X and the Y components. So let's go ahead and do that right now. So solving for the X components, we have sum of the forces in the X direction is equal to, and we're just following the formula that was in that NCEES supplied reference handbook on page 63. We've got 30 newtons. If you take a look at that, that's a purely X component. There's not an angle being applied there, so it's just 30 newtons plus 45 newtons times cosine 30 degrees plus 60 newtons times cosine of 60 degrees plus 75 newtons times cosine of 90 degrees plus 90 newtons times the cosine of 120 degrees is equal to, and that sum value comes up to be 54 newtons. So this is where Chris was getting stumped, was right here. In this plus 90 newtons times the cosine of 120. Okay, so this was pulled from one of his reference handbooks or one of his reference materials that he was using, that he purchased. And he's like, why is that an added value? Why is that a plus value? Because we know that this is pointing in, I think it's quadrant 2, but it's pointing to the left, which we know it's going to be, we think that it's going to be a negative X component value because it's in that quadrant. Well, yes, it actually is a negative value. But if you take a look at it, 90 times the cosine of 120, what do you think that is? You think it's a positive value? You think it's a negative value? 90 cosine 120. It's actually negative, okay? So even though he's adding it here, he's adding it because he's following the sign convention. He's just adding all of these X components up. The laws of trigonometry and the rules of trigonometry are going to handle the sign conventions as long as you stay consistent. So stay consistent with your reference point and your angles, meaning we're always going to reference this same plane here. Everything is going in that in that same direction. So as long as you keep that consistent and you're adding all of those, the sign conventions will take care of themselves. So 90 newtons times the cosine of 120 is actually minus 45. Okay, so you get all these values. These are all going to be positive, positive, positive. 75 cosine 90, I believe that's going to be 0. 75 cosine 90. Yes, that's 0 because that's a purely vertical component. There is no x component. And 90 times the cosine of 120, yes, that's going to be minus 45 because it's going in that opposite direction. So your sign conventions will take care of itself. All right, so that's the x component side. Now let's do summing in the y component. So sum of the forces in the y direction is equal to 30 newtons times the sine of 0 plus 45 sine 30, 45 newtons sine 30 degrees plus 60 newtons times sine 60 degrees plus 75, because that's a purely vertical component, plus 90 newtons sine 120. Okay, so that value is 227.4 newtons. So then when we solve for the resultant of that, we've got the resultant is equal to x squared plus y squared, which is actually sum of the forces in the x, sum of the forces of the y, which equals the square root of, what was it, 54, yep, it's 54 plus 227, we get a resultant force is equal to 234. 234. Oops, I'm sorry. We got to square these. Remember to square those. 234 newtons. So that's how you solve it. That's exactly how you solve that problem. So don't get tripped up with the sign convention. Stay consistent. The laws of trigonometry will iron out the sign conventions. You do not have to worry about it. So hopefully that helps, guys. These resultant forces, do not make them more complicated than they are, and really just stay consistent with your sign conventions and you will be fine. So hopefully you enjoyed this. If you want to learn more about the FE Focus Formula Accountability Program, please check out the links below. I'd love to have you on board. We set up an entire custom-built study plan for you. You get access to me directly as your one-on-one tutor for all of these problems. I only work with the core subjects like math, probability, statistics, and a couple other subjects. So hopefully this helps, and if you liked it, please share it with your friends, and I'll see you in the next video.